Welcome, Honors Algebra 2. Welcome to Mr. Patterson's class. If you're here viewing this is Mr. Clendenin again. This week we're going to look at some conic sections, which are your parabola, your circle, your ellipse, and also the hyperbola. We're not going to look at the hyperbola this week. We're going to look at those first three. And today we're going to look at a parabola. And we've looked at a parabola before, but we're going to get a little bit more in depth with a parabola today. Because there were some things we didn't talk about, mainly something called a focus, which we're going to look at here. Here is our general equation for a parabola. Now, remember in these equations, it makes a difference if there's a minus sign or a plus sign in your equation. Remember, whenever it's a minus sign in your equation, anytime you plug a number in or anytime you pull a number out of there, the sign will switch. For instance, if you put a -2 in here for this h, you'll have x minus -2 in there, so you would get x plus 2 inside those parentheses. Where if you start off with x plus 2 in there, if you pull out and say what's h, you got to remember that that's it switches signs on you to -2. Okay, so you might remember that from past work here with equations that we have done. The new variable in here is p. We'll talk about what that stands for. We use p for parabola. But our vertex is sitting in the equation right there in front of us. It's that h and k value. So let's actually what we'll do is we'll talk about this equation as we look at this first problem I have down here. So number one, what we probably ought to say is, how do we know this is a parabola? Well, because only one variable is getting squared. The y is not getting squared. So anytime only one of your variables gets squared, it's a parabola. Okay? So we can look at this and say, all right, what's our vertex? Well, we got plus 3 in here on our x, so that'd be minus 3 for our h. Our k values right here with our y. So y minus k, if it's y minus 7, then k would be 7. Okay, so again, plus 3 here gives me a -3 there. Minus 7 there gives me a positive 7 there. So that's that switch of signs that I'm talking about. Okay. Now, one thing we didn't talk about when we discussed parabolas before was this item called a focus that sits inside of the curve. Now, what that is, if you think about, since all you guys have your driver's license now, your headlights on your car are what you would say are parabolic in shape. If you looked at your headlights on your car or on a flashlight, that lamp is parabolic in shape, and the light bulb sits actually where what is called the focus. Now what happens is the light from the light bulb comes out of that light bulb and it hits the reflective background of your headlight and it gets shot straight out in front of your car. No matter how this light, even when it goes backwards out of the light bulb, it gets shot straight out of the car, and that's why your headlights on your car will focus that beam of light out in front of you. Okay. Also, if anybody has a satellite dish on top of their house, or maybe a neighbor does, you can look at it. It works the opposite way on a satellite dish. On a satellite dish, there's this little box, we'll call it a box, sitting out in front of that satellite dish. That's actually the receiver. And what happens is the satellite, whatever you want to call it, the beams come from the satellite, and your dish, they hit your dish and it gets reflected straight in. No matter where it hits this dish at, it gets reflected straight to that focus, which is where your receiver is, and that's how you can pick up all the channels with your satellite dish. So it kind of works in reverse on a satellite dish. So that's the purpose of the focus. That's what the focus does, and it's sitting inside of your curve. Okay. Now this new variable in this equation, this p value, how it comes into play is it is the distance from vertex to focus. Okay. So that p value is the distance from your vertex to your focus. It is positive if the parabola opens up, and it is negative when it opens down. Okay, so on to our first example here. We found our vertex. We looked at our h and k. We switched our signs like we know we should. Then we got this -12 sitting right where that 4p is in our equation. So we would simply say 4p equals negative 12, divide by 4, and we get p equals negative 3. Now what does that tell us? Let me clear some room over here. If we were to sketch this parabola, we know our vertex is at negative 3, and then we'll just say up here at positive 7. That's where our vertex is. Since p is negative, what's that tell me about my parabola? It opens down. So my parabola is opening down. Where is that focus at? Well, it would be 3, which would be 1, 2, 3, would take me down to 4. It'd be sitting 3 units away from our vertex right there. That is where our focus. So what will be the coordinates of our focus? It would be negative 3, comma, 4. Okay, you will have a problem on your homework where you're given an equation like this and you'll have to find the vertex and the focus. You'll have to use this p-value to find that focus. Remember, if it's positive, if it had been positive 3, then we would have went up 3 to find our focus. Also, positive would have meant my parabola would have been opening up. Okay, hopefully that's not getting too confusing on that drawing for you there. All right, let's look. What do we have next here? So if we have an equation, remember what makes this equation, how do we know this equation is parabolic? Is it a parabola? Because we only have an x squared. Okay, the y is not being squared. So that means this is a parabola. So what's that tell me? I should be able to write it in that format. Y minus k equals 4p times an x minus h quantity squared. And if I can write it in this format, then I should be able to pick out my vertex. I should be able to find my p-value and use my p-value then to find my focus. Okay, and my p-value would also tell me if I open up or if I open down. Well, how are we going to make this equation look like that? Some of you might be already thinking ahead. We are going to have to complete the square. Everybody remember how to complete the square? All right, if you don't, pay close attention here. I'm going to walk through this one. And remember, we're trying to make this look like that equation. So remember when you complete the square and you have this constant term, this plus 9, we're going to get it out of the way. When we can put it on the other side of the equation to get it out of the way. And you say, well, why would we put it over there? Well, it's not so bad because we've got to have that k value over there on that left-hand side anyway. Now that doesn't mean the k value is negative 9. It might change. We'll see. Okay, when we complete the square, can we have a constant in front of that square term that's not equal to a 1? The answer is no. So we have to factor that 4 off of there. Remember what we're going to do here, or why do we just do that? Because we have to have a 1 right there. Now we're going to fill in the right number here to make a perfect square trinomial. How do we figure out that number? Half of this middle term here, this plus 2, so we're going to take half of it, which is 1, square it and get a positive 1. Now why do we do that? So that that trinomial right there can be factored into x plus 1 quantity squared. And that is starting to be our x minus h in our formula. All right. Now remember that this 1 came out of nowhere. It wasn't there. We put it in there. But did we just actually add 1? No, we actually added 4. So what do we do after we add 4 out of nowhere on the right-hand side? We have to come over here and add 4 on the left-hand side. And that gives us y minus 5. Equals, what do we have? We have 4 times x plus 1 quantity squared. Remember this plus 4 here, that's important because it's an equation. There's an equal to sign in there. And if we add 4 on the right, we have to remember to add 4 on the left to keep it balanced. All right, or it won't be an equal to sign anymore. And look what we've done. We have just converted our equation into what is called vertex form. So now, can anybody tell me what the vertex of this would be? Positive plus 1 in there, so what's that tell me for my h? Negative 1. Minus 5 here, what's that tell me for my k? Positive 5. Can anybody tell me which way it opens? Does this open up or down? So right now, let's start to build a graph here. -1, +5. So there's my vertex. Which way is this thing opening? Well, the p-value would tell me. And how do I find my p-value? I take this, whatever number's here, happens to be a 4, and I set 4p equal to 4, because that's what's sitting in my equation up there in front of that set of parentheses. So p equals 1. So this is telling you two things. Since it's positive, it's telling you it opens up. It's also telling you how far away the focus is. The focus is 1 unit away up, because this has, now we know our parabola has to open up, and our focus then would be 1 unit away, sitting right there at 6. Or actually, what would the coordinates of our focus be? It'd be -1, 6. Now I will tell you this, we got lucky on this one, and on the first one actually. That number sitting in that 4p spot was divisible by 4, so we didn't get a fraction here for our p-value. It is very common to get a fraction for that p-value. Just remember two things. Is it a positive number? That means it opens up. If it's negative, it opens down. And whatever that number is, if it's a half, then that's how far you move to find your focus. And you're either move up a half or down a half from your vertex over here. Okay? On your homework, you will run into some fractions for your p-value. Well, just add your fraction, subtract your fraction from that y-coordinate is what you end up doing. All right, you see there how it went from 5 to 6. There's where the +1 comes into play. Well, what if our p-value was equal to a half? Well, then this would have been 5½ over here. That's all. Okay, so watch out for that on your homework. It's a little heads up. And the last thing I want you to be able to do, or we want you to be able to do, is to work backwards and write the equation. So here we're given our vertex is at 5, 2, and our focus is at 5, 4. And let's just write down our equation real quick. Y minus k equals 4p times x minus h squared. And let's start filling in some things. Well, our vertex is our h and k, so we can take that 5 and go plug it in. And remember, it's +5. When you plug it in, it'll say x minus 5. This 2, we could plug in for our k value, and again, it's positive, so it'd be y minus 2. The only way either one of these would change to a plus is if you plugged in a negative number and had a double negative working, a minus and negative, which you would change to a plus. Okay, keep that in mind. The only thing we don't know is our p-value. So you might be able to figure it out from what we're given over here, or it might be safest just to sketch yourself a quick little graph. Say my vertex is at 5, 2. There's my vertex, 5, 2. My focus is at 5, 4. So number one, which way is it opening? Well, the parabola always has to wrap around the focus. It's opening them up. So what's that mean? P is a positive number. What will that number be? Whatever that distance is right there. Well, what's the distance from 2 to 4? 2. So P equals 2. So we plug a 2 in here, and we get the equation y minus 2 equals 8 times the quantity x minus 5 squared. There you go. A little bit long video today. Just the way it had to be. Sorry about that. Submit your picture again like you're doing as usual for your homework, and your homework is right here, and I will also attach it to my class. If you want to print it out, you can. Same type thing there. State the vertex and focus on number 1 and sketch a graph. Complete the square on number 2. Find the vertex and focus. You don't have to sketch the graph on that one. And number 3, write the equation. You can sketch the graph if it helps you. Okay, and don't be afraid or don't be shocked if you have p-values that are equal to fractions. Just add them or subtract them from your k value to get the right coordinate for your focus. Okay? See you tomorrow.